So today we are going over 4.2. So we are on page, this one, 16, solving quadratic equations by graphing. So this one you already know how to do. This should be a very short lesson. We already went over this. We talked about the solutions already because it's technically part of 4.7 as well. So my goal is to start 4.3 today as well. This 4.3 is a monster. It must be slain. It's so long, but the reason it's long is because I give you so many examples. Okay, solving quadratic equations by graphing. A quadratic equation is a quadratic function set equal to the value of 0. Whether the equation, where it crosses the x-axis is the solutions. It's the roots, the zeros of the function. These all are synonymous. What do I mean when I say synonymous? 16, top of page 16. What's synonymous mean? Same. Not just similar, they literally mean the same thing. If I'm asking for the solutions of an equation, if I'm asking for the roots, if I'm asking for the zeros, it's the same thing. I'm looking for the x-intercepts, where the line crosses the x-axis. Okay, this, like we knew about this, right? Because we talked about this already in the first two sections. I graphed a problem. I'm like, how many solutions does it have? And you're like, 2, because it crosses twice. It was on your quiz. All right, so how do you actually solve by graphing? You can plug it into your calculator and then analyze menu, analyze graph, zeros. I mean, we're going to do this in our calculator anyway. So although you don't need hats, you do need to have your calculator out. So if it touches the graph at 2 places, right here, has 2 unique real solutions, touches at 1 point as 1. If it doesn't touch it all, it has no solution. So, what? No, the solutions are the x-intercepts. Has nothing to do with the y.
Okay.
So hopefully this will be a warm-up. What type of solutions each graph has? So let's go around. Let's start with Lauren. A, how many solutions?
2.
2. Right here. Oops, come on, pop up. Right there and right there. Come on. Maybe. Yeah, there it goes. Because this is the line of y equals 0. It's the x-axis. Touches 2 points. How about this one, Ashton? B.
1.
Literally has 1. This one had 2. What about C? So keep in mind, this is the line of the x-axis. Has none. 0. Okay, cool. You're on the bus? Cool. I already was told that. Thank you. Okay. How about D, Isabella? So I'm going to highlight the x-axis just so it's easier to see. Yeah, exactly. It has 2. Right? It crosses the x-axis twice. And lastly, Miranda, how many does this one have? E. None. So you would say there's no solutions. Okay, how do you actually solve a quadratic equation by graphing on a calculator? Let's try this out.
Graph 0, so 6, 1.
Where is yours? Why? Isn't this happened last time? You need to charge it. Huh? Where is it right now? Is it in your bag?
No, it's not like that.
Okay. Oh, actually I can't. I don't have calculators in here. So, I don't have any.
You want to use mine?
Yeah. What?
You want to mine?
No, you need yours.
Can I charge?
No, because I don't have the charger in here. So you guys need to bring your calculators every day to class. We're going over calculator skills. It needs to be charged as well. I mean, you can leave them in here to charge, but you need them for class. So, if you don't have your calculator and I see you're not following along and working with this, going over calculator skills, you're going to get docked participation point because you're not actually participating because you're not practicing your calculator skills. You need to bring them every day. You signed your syllabus. You said you'd bring it. Cool. Just being clear for all the people who are going to watch the screencast so they hear my same speech. Okay, so if you open it up and it goes automatically to this page, you can click add graphs, but if you're at the home page, you just go over where it says graph. Okay. Oops. Oh no, where's my entry line? How do I get back to it? Tab. Okay, cool. At least we're all good with that. Okay, so first thing, turn on the calculator. Click new document, add graph, do not save previous document. Type an equation and press enter to graph. Did I write an equation for me to use? Yes. X squared minus 2x minus 8. So let me just make this a little bigger. Okay, so I'm going to insert x squared minus 2x minus 8. Okay, and I push in, oh, wait, did I, oh, because it shouldn't be in there. Okay, so x squared minus 2x minus 8. What'd you get?
I pressed tab.
What's in there?
REL.
Relative, so that's relation. So you need to go menu, graph, entry, edit, function. Cool, and now you have this. Okay, so I graphed my equation. All right, so let's see. X squared minus 2x minus 8. It's the one that's on the paper. All right, so type, what? What are you talking about? I'm on page top of 17. I'm going through the directions. Do you not have this page?
No, I don't. Just down here.
Right here. Do you see where I'm pointing? Right here.
Yes.
So it says f1 of x. So I'm trying to do the same example with you that I did on the page. Okay, type in the equation, press enter to graph, press menu, analyze graph, 0. Menu, analyze graph, 0. I go to the left of the 0, click, and then I scroll to the right. So it shows me 1 0. The issue is, how many zeros do I have? 2. So I have to do it a second time. Oh my gosh. Okay, menu, analyze graph. Come on. Analyze graph, 0. So I have to go to the left and to the right of my 0. Then I see 2 popped up. So press menu, analyze graph, 0. Set lower bound by clicking left of your first 0. Set upper bound by clicking right of your first 0. Repeat with the second. So I'm doing the same example that's on your paper. Notice how the first time I went to the left of my whole graph and to the right and it only popped up my right 0. You have to do it a second time. If you see, there should be 2. Like, how many times across? 2. Okay, so now that we've done one example, let's go ahead. Where's my mouse? Let's go and let's do this example 1 right here.
Yeah.
Y equals 2x squared plus 4x plus 7. Find the solutions of your parabola by graphing on your calculator. Make this a little bigger. So if you need to clear it, I can click tab, scroll up, and then I can just delete all this. You also can do menu, actions, clear all. Okay, so 2x squared plus 4x plus 7. Yeah, so we know it's going to be 0. Let's see, what will our graph do if I try to find a 0? Ah, it literally tells you no zeros. So if you try to do it, it will tell you none found. He can move his bag. Just inspect it. Huh?
Sorry, here.
So for this part A, guess what? There are no solutions. 0 solutions. It's not crossing the x-axis at all. Let's go and let's do C, just so we have one more practice, and then we'll keep going. So you come back here. Now I can push. Here's another way to clear it besides delete. Menu, actions, delete all. Do you want to delete everything? Yup. And then I push tab and now I'm like cleared. This is if you had like 50 equations on there, maybe like 5. You don't want to go delete them all. So that's another way of doing it. So let's insert our C. We're going to do C next. X squared minus 2x minus 1. So there's 2 solutions because it crosses the x-axis twice. So you do menu, analyze graph, 0 to the left of your first 0. Pops that guy up. Menu, analyze graph, 0, and I have to go left of my second 0 and right.
How many solutions it is?
Find the solutions.
So you have to find them.
So I found my points, yeah.
Wait, I really don't understand how to find the solutions.
So, menu, analyze graph, 0.
Menu 6-1.
Menu, analyze graph,
Analyze graph,
zeros, and then you go left of your first 0.
But
Mine's
Drag it, drag.
I know.
I can help you. I can
so
do
Brian.
It's
Let
fine,
the
I
teacher
kinda
do her
Here,
job.
hey, it's, I mean, I like when other people help, but what's the issue, Isabella?
I can't really do it. Like, So I can just drag it to.
Yeah.
Yeah, drag to the left of
Wait
it.
1 second. Can I talk, please?
Wait, it's fine. Okay, so drag it to the left, just like we did up here.
Just like anywhere to the left or just to the
Left
left?
of your zero. It has to be left. Has to be anywhere left. Yep.
So I could do it like there.
Yep. Anywhere left of it, and now drag to the right. Nope, you didn't click.
Yeah, she
Okay,
clicked it.
keep going. Now right there, pops up your first one. But this is if you keep
So
scrolling to
it's
your
just
right.
any.
You keep scrolling to your right, it pops up only your second. Only pops up one at a time. So there's one of them, and then you have to go menu. We have to find our second one. So I'll find both of them. So what happens if your numbers are overlapping with each other? You can literally click on them and drag them so you can read them easier.
When I did
Yes, you
mine, it would just stays there.
click.
Oh, mine says like at the beginning it says, I know how to do it, but mine says
Okay.
Y. Mine says Y.
Where? Relative. Rel.
It's
Yes, but if you want to change it, you can say menu, draft, entry, edit, function. No, you don't have to, but you can put it into row function. We are graphing this equation. So since there's no, so this is teaching how to find the zeros. It's very similar to what we've done before. So what I'm trying to do is like, not rush through this one, but like, we have a pretty good sense of what this lesson is already. So teaching how to like actually do the zeros on the calculator. Because what we did before, we did the min and max, right? But now I'm teaching how to find the zeros, and then like hopefully like 20 minutes will be done. We can start on the next lesson because the next one's really big. It's just more calculator skills, making sure everyone is clear. How do you find the minimum? How do you find the maximum? How do you find the zeros? What's the number of zeros? Huh? So you do, hold on. Okay, ready? So I go menu, analyze graph. This is what's this page 17 is about. And I go 0. Then I go to the left of my 0, click and drag to my right, and it pops it up for me. Yeah. Of the x-axis and your parabola. But the parabola can either have 2 solutions, 1, or none, depending on how many times it crosses the x-axis. Okay, so we see there's 2 solutions on this one. Negative 0.414, oops, comma 0, that's one solution, and my other solution is going to be 2.41, comma 0. And notice up here there was no solutions. On A, there was no solutions, because there's literally no intersection. Okay. So let's doing this one. Wow. All right, solve x squared plus 2x minus 15 equals 0 by graphing. Begin with the equation of the axis of symmetry. Make a table of values. Hopefully this will be semi-review. Begin with the equation of axis symmetry. Axis of symmetry is negative b over 2a. Come on, pop up. Negative b over 2a. And notice this is in standard form. What is my a? Right, it's the coefficient from x squared. It's 1. What's my b? 2. And I mean, I guess I could say my c is negative 15, but I don't really need it right now. Okay, so negative b, so negative 2 over 2 times 1. What is negative 2 over 2?
1.
Negative 1. So that is the axis of symmetry. So something that might help with you guys graphing. Oh my gosh, come on. Okay. Is if I draw my axis of symmetry, how's the left side of the graph going to compare to the right? Left of the axis of symmetry versus right of the axis of symmetry. How do they compare? Axis of symmetry. It's literally going to be mirror images of each other. They're going to look the same. If I am 1 unit to the right of the axis of symmetry, it will have the same y value as 1 unit to the left of the axis of symmetry. Symmetric. Okay. So make a table of values. So here's my x. Now I'm going to change color. Here's my x, here's my y. I'm going to pick a couple points, and they're all going to be around my axis of symmetry. So I'm going to pick, let's see, 1, 2, 3. My middle one I'm going to put as -1. Right, and then I'm going to pick the values around it. So 0, 1, -2, and -3. So if I plug in 1 into the equation, x squared plus 2x minus 15. So I have, let's see, 1 squared plus 2 times 1 minus 15. 1 plus 2 minus 15. So that's -12. If I plug in 0, 0 squared plus 2 times 0 minus 15. 0 plus 0 minus 15. Oh man, this graph. Do I need to put 5? Or do I need to put 15? Do we have questions? Are we calculating it? So I put in -1, -1 squared plus 2 times -1 minus 15. 1 minus 2 minus 15. So it's -16. And then what's the y value of negative for when x equals -2? Yeah, so whenever you're around the vertex, if you're one number above the vertex, it'll be the same y value as one number below. If you're 2 numbers above the vertex, you'll have the same y value as the x that's 2 below the vertex. Okay, so this would be -15, this would be -12. Okay, so I need to add some lines. 1, 2, 3, 4, 5. So my vertex is at -1, -16. 1, 11, 12, 13, 14, 15. So it's like right here. Then I have, let's see, 0, -15. 1, -12. What if I put a 2 in there? Do we know what the y value would be? All right, 2 squared plus 2 times 2 minus 15. 4 plus 4 minus 15. So that's -7. So 2, -7. Because ideally we're trying to graph it and then find the graph the function, identify the solutions. So I see I'm starting to have a parabola form, but I want to know where is it actually going to be crossing the x-axis. So I should have picked a better number. I shouldn't have had that -15. Okay, I'm picking another number like to the right. I'm going one number to the right of my axis symmetry, plugging in what's the y value. Doing 2 numbers, right? 2 to the right of my axis symmetry. I'm doing 3 numbers to the right, find the y. I'm doing 4 numbers because I really want to be precise with what x value gives me a y value of 0. So I have 9 plus 6 minus 15. That gives me a y value of 0. So 3, 0. So I'm trying to graph this parabola, but the whole reason we're doing this is to solve it by graphing. We're trying to find the solutions by graphing. What? Correct. So I taught you how to find it on your calculator first. So this is one side of my parabola. Yeah. It's just going over it again because confusion. Okay. How does the right half of my axis, how's the right half of my graph, right of the axis symmetry compared to the left half? How will the left half look?
Same.
It's going to be the same. Okay, so let me prove it to you. So you see how, come on. So you see how this is 1 over and 1 up from my axis symmetry? It's 1 to the right and 1 up. Oh my gosh, I'm trying to draw an arrow. Draw the arrow. Okay, that means I'll have one. I'll have a point that's 1 to the left and 1 up. And I'll have a point that is, let's see, 2 left and a couple up. So what I'm doing is everywhere I see a point 3 to the right, I'll have a point 3 to the left of my axis symmetry. I see 4 to the right, I'll have a point 4 to the left of my axis symmetry. And it's going to be symmetric. The left half looks like the right half. Okay. So we're solving by graphing, and then we're going to later do factoring.
How did you get 0?
0 and -7. Wait, what? Where? This is a -7. So the couple of values I found, they were only the ones that were right here. That doesn't help me with solving the solutions because that has to be right across the x-axis. This isn't a great, I realize now this is not a this is not a great solution. But the whole reason, like I'm showing you, okay, we're graphing the same as we've been doing. It's just now I'm asking you what are the solutions. You just have to find the 2 coordinates where I'm crossing the x-axis. Or maybe it only touches it once. Maybe it doesn't touch it at all. Here, what are the solutions going to be? So I have 3, 0 and -5, 0. So it always goes x, y. So 2 places it crosses the x-axis are right here and right here. 3, 0, -5, 0. So this is more practice graphing because you betcha you're going to have part of this on your test. So let's go ahead and let's do example 2. This one's much better. Solve by graphing, note the number of zeros. So first I need it in standard form. So I need to get everything to the left side. Why am I choosing the left side? Because it has my squared that way. So to add 8x to both sides. And I need to add 11 to both sides because I need everything to be on one side. So I have x squared plus 8x plus 16 equals 0. So I think this one will make more sense. Because it actually fits on the graph, the axes I gave you. The last one did not fit on the axes. Do you know how to graph this?
X squared is A, 8x is B, and 16 is C.
So A is the coefficient in front of x squared, which is 1. B corresponds to the number in front of x, which is 8.
How do you know that it's not like x to the second plus 16 plus 8x?
Because the order has to be ax squared plus bx plus c. It has to go in order of highest exponent to lowest. So, okay, I have all of my a, b, and c. I need to find the axis of symmetry. Negative b over 2a, so it's going to be negative 8 over 2 times 1. So that's negative 4.
So -4 is the
Vertex. It's the axis of symmetry, it's the vertex. This is where the vertex occurs.
Wait, why wouldn't you just simplify it? What happened to the denominator?
What denominator?
Like 2 times 1 is just 2.
2 times 1 is just 2. Negative 8 over 2 is negative 4.
Okay.
No. Okay, I'm just going to pick a couple numbers. So I'm picking, so I have my axis of symmetry. I need to find what the actual vertex is. So if I plug this back in, I can find the vertex. The vertex is literally going to be, the x is your axis of symmetry, and then you just plug in the axis of symmetry into your function. That's what your vertex is. The x value from your axis of symmetry, whatever y value you get when you plug this back into the equation. So the y value of -4 is going to be, of when x equals -4, see -4 squared plus 8 times -4 plus 16. 16 minus 32 plus 16. So you can use your calculator. What is this equal to? 0. So literally my vertex is -4, 0, which is right here. And remember, vertex are always the maximums or the minimums. Wait, so how many zeros, how many solutions, how many roots do we have here? Do we know? There's only be one. Because remember, our vertex is either our maximum, upside down u, or a minimum, a u. And since the vertex is on the x-axis, I'm only going to be touching the x-axis once. Because our graph's either going to look like this, or it's going to look like that. It's only going to be touching it once. So we already know our answer to the solution to the 0, but now we just have to finish like graphing. So I really want to leverage this axis of symmetry. I want you guys to understand what it means to have an axis of symmetry. So I'm going to plug in one number to the right. I'm going to plug in a number that's 2 to the right, and I'm going to plug in a number that's 3 to the right of my axis of symmetry, and I'll find out where the y values are. And then once I graph that, I'm going to reflect it across the axis of symmetry. Okay, so let me plug in -3. So I have -3 squared plus 8 times -3 plus 16. 9 minus 24 plus 16. What will this be?
How come you did -3, -2, -1?
Because I'm picking numbers 1 to the right of my axis of symmetry, an x value 2 to the right, an x value that's 3 to the right.
If -4 is the vertex, and wouldn't the vertex be like in the middle, so it would be like -3, -2, and then underneath would be -5.
So that's the way I taught you the last section, which is fine. But what I want you guys to now understand is the axis of symmetry, because I don't feel like we really understand how to use it. Because I taught you guys how to like make it easy for yourself to make a little table,
So you're just
which is
going
great.
from, like the top down, like -3, -2, -1, 0.
Yeah. And then guess what? The same y values for these are going to be the y values for the ones. Okay, let me rephrase that. So the y value for my x, so I have an x value that's 1 over. Whatever y value it's at, it will be the same y value that's 1 to the left. I'll have a y value for an x that's 2 to the left of my axis of symmetry. It'll be the same y value as the x that's 2 to the left of my axis of symmetry. Okay, so let's just go through this, and I feel like you'll see it. So when I add these together, I get 1, -2, so plug in -2. Be 4 minus 16 plus 16, so that's just going to be 4. And I plug in -1. Minus 8 plus 16, I get 9. So what this means is I have a point at -3, 1, -2, 4, and -1, 9.
So where it says x to the second,
Just a moment. Just a moment. Okay, what is your confusion? I've drawn half my
So-
parabola.
X to the second plus 8x plus 16 equals 0. We totally just disregard the 0 and say that it's just x to the second plus 8x plus 16.
Right, because when I said equal to 0, that means I'm trying to find the x-axis. I'm trying to find where it crosses the x-axis. There's only one point where it does.
So it's
Yeah.
not like, oh, okay.
There's only one point where this is true, and it's -4.
Makes sense.
Yeah. Well, the vertex isn't always at 0. It's because I plugged it in, plugged in -4, and I got 0. So right away, like we discussed how that's the only solution. So now what I want you to see is, okay, so we used to go,
Do the same thing on the other side.
no, I'm not going to redo all the math. So our vertex is at -4. So what we've been doing is having the values that are around it. But I know the value for -4 is 0. The value for -3 is 1. The y value when x is -2 is 4. And so I know, so we don't have to redo all the math, I know that the numbers, the x 1 to the right and the x value 1 to the left of my vertex have the same y value. That's what I was showing with these arrows over here. I know the number that is 2 more than my axis symmetry. Know the x value that's 2 less than the axis symmetry will have the same y value. So another way to see it is if I am 2 over and I go up 4, I'll go 2 to the left and up 4 for my second value. I'm trying to help you leverage the axis symmetry so you don't have to do as much math. So I know that the left side has to look like the right side of my graph. So notice that I will have a y value of 9, 3 to the left of my axis symmetry at this point, up here. So I didn't actually do the math for the whole left side of my parabola. I only did math of one side. And that's what I was trying to show you guys before with the whole like table right here and drawing these arrows, trying to show you what the axis symmetry means. Left side is same as right side. So I only have to solve for the y values on the right side or the left and then reflect it across. Okay, so we see there's only one solution. It is at the vertex. Questions? Does axis symmetry make more sense now? Maybe. That's my goal. Do we have any more? What was your question before? You answered? Okay. Cool. Yep. Do you want to get to the right page of your notes?
Oh, sorry.
We're not done.
I was just on.
Okay. All right.
Are there any
Estimate-
more examples? Sorry, real quick. Are there any more like, examples of this that you can
Literally, you just have to graph. It's what we've been doing, but you just have to find where the solutions are, where the crosses the x-axis. Okay. Estimating solutions. Some quadratic functions. Equations have solutions that are not integer values. Solutions can be estimated by examining between which integer values the function changes from positive to negative or negative to positive. So if you're switching from a plus to a minus, at one point you must have crossed over the 0. So this is going to be kind of like an example of what we just did. The only difference is, Isabella, that we're going to be estimating where it's crossing the x-axis because it's not going to be a nice number.
It's gonna be like a
Decimal. So we're going to estimate between which two numbers it is. Okay, make the table of values, blah, blah, blah. Okay, first thing we're going to do, find axis of symmetry. Where will the axis of symmetry be? Axis of symmetry.
so it's
What? But the difference is our 0 up here was a nice integer number, -4, 0. Up here, our solutions were nice integer values, 3, 0 and -5, 0. When I come back down here, this is not going to be. I have to say between which two integers the roots are located. It's just like a little different, but it's the same process. It's just I'll see like, let's say my parabola was crossing like this. Like right here, this is not an integer value 0. It's crossing between like -2 and -3. That's all the difference this is.
So it really doesn't matter where it crosses on the y-axis, does it?
No. The y-intercept doesn't matter. That just tells you how much you started with.
Okay.
Yeah.
And then this is not in standard form, then it's 4x is before the x's.
Right. So if I would rewrite this in standard form, so -x²
You could just
plus
double everything
4x
like
plus 8. Well, what is 2 plus 1? Is it the same thing as 1 plus 2? Yeah, so commutative property of addition. Since I'm adding these terms together, it doesn't matter the order I add them. So my A is -1, my B is 4, and my C is 8. We know axis of symmetry is -b over 2a. So negative times 4 over 2 times -1. -4 over -2 is 2.
So vertex is 2.
The axis symmetry is 2. I know my vertex will occur when x equals 2, but I don't know what the y is yet.
Oh, so 2 so far is,
Just the axis of symmetry, which is what I'm drawing right here.
if we put that in the middle of our graph, so it could be like 2, and then above that it would be 1, 0, then below would be 3, 4, or are we going away from that?
It's not away. I'm trying to show you guys, like, why. Why can you only find 2 of them and you know the 2 below as well?
Okay.
So we can do that. So I'll draw my table like we've been doing. I'm gonna draw my table like we've been doing. Okay, and in the middle I'll put 2. What?
But it, like, I'm sorry, I'm just like so confused.
I don't understand what you're asking me.
So I'm just confused. Are we always allowed to do like 2 or whatever we get for AOS in the middle?
Yeah,
Or can we just
that's
do
fine.
It on the top?
I mean, you can put in the middle. So, like, so this is a new thing I'm trying this year of saying, like, put your axis symmetry in the middle. That way you have the points around it. Because last year people struggled with knowing which numbers to plug into graph.
Yeah.
So I
we
said
just
focus
always
around
do-
your axis symmetry. But then what people did is I was just glancing and there was too much calculation for all 5 lines. I don't want you to have to calculate all 5 lines because I already know these values. I already know these y values and these 2's y values will be the same. The y value x equals 0 will have the same y value x equals 4 because it's going to be symmetric around this axis of symmetry. Yes.
Is there a reason why the line is dotted?
Well, it's not like a solid line. I'm like trying to lightly draw it in the sense. So
It's
the
not
reason,
gonna stay there.
right, you could like erase it at the end. But why I'm drawing it is I want you to see the left side is the same as the right side. So all the x values to the left, course, and the y will correspond to the x and y values to the right side. Symmetry means the same. It's like we're looking in a mirror. Okay, so let's plug in.
All one side.
Huh?
It's all one side. Pretty much. Like
Pretty
2,
much, and then you can
0,
just
and
graph
you
the
can
other.
write the other.
And then you can just graph the others, write the other ones. So I only have to solve the 0, 1, and 2, and then I'll know 3 and 4. Okay, let's plug in 0. So I have negative 0 squared plus 4 times 0 plus 8. So that's just going to be y value of 8. Automatically, I know I'll have a y value of 8 for x equals 4. Plug in 1. So it's negative 1 plus 4 plus 8. Huh? Oh, did I mess up again? 12. This is 11, so I'm off the graph. Dang it. (16) minus 4 is 12, and I know that's 11 as well.
Yeah. I got 13. But like 1, I did negative 1. Is it 5 plus 8, 13?
How do you get 5?
It's 4.
Oh, it's 4 times. No, because negative 1 times negative 1.
It's not negative 1 times negative 1. It's negative of 1 squared, because there's a negative in front of x squared. It's not negative x squared, it's negative of x squared.
Oh, so it's like 1 times 1 negative.
Yeah. So I have 0, comma 8, 1, comma 11, so that's about right here. 2, comma 12.
Oh, I see. I see.
Ooh, so we're supposed to be estimating where I'm crossing the axes, right? I'm really far above the axes. So what if I just plug in like, let's plug in 1 or 2 more numbers and let's see what happens. If I plug in 5, because I have to see, because right now I don't know whether to draw the line going here or should I draw the line going here, right? I don't know which integers to go between. So I need to have, like, I need to find x value. I need to keep plugging in x's till I find a y that's negative, and then I'll know between which 2 integers I crossed.
Don't we know that the vertex is already 2, 12?
Yes, we already found that.
So we can plug that in and make it.
I already have the vertex up here, right here. The vertex is our maximum, because you see how I have my U shape facing down?
On the test or anything, if there's like a part that you know it's gonna be like 12, the graph and it goes to 10, will you do it?
Well, no, I'll make sure that it actually works out, just like the last quiz. I made sure it works out. And when you plugged in numbers, you only got nice integers. Okay, so negative, let's see, 5 squared plus 4 times 5 plus 8 I have to keep going till I find a y value that's negative, so I know which numbers I'm crossing between. Negative 25 plus 20 is negative 5 plus 8. Ugh, that's negative 3. Wait, no, it's positive 3. Positive 3. So that means for an x of negative 1, it has positive 3. Okay, so I gotta plug in another number, 6. Ugh, negative 6 squared plus 4 times 6 plus 8. 36 plus 24 plus 8. Wait, sorry, minus 36. That's 12. So this is negative 4. Which means when x equals 2, I have negative 4. Okay, so negative 2, comma negative 4, negative 1, comma 3, 5, comma 3, 6, comma negative 4. What?
Wait, where'd you get? Okay. So I get. Wait. What? Oh. So it's not okay. Not in there.
So I'm like centered around my vertex. So do we know between which integers we cross? Oops.
Say you're not supposed to use your calculator, but you got like in between like a 5 and a 6 or something.
I'm not gonna do this on your test. This is just good practice to tell which integers we're crossing.
I'm just gonna do on one.
Yeah. There's stuff like this on your homework.
Okay.
What?
Homework takes me like 5 hours.
That's crazy. It shouldn't be that long.
The graphing homework takes me always like graph.
Shouldn't take that long.
I mean, it doesn't take 5 hours, but it takes longer. It's way longer.
Yeah.
Yeah.
It's also why I don't have it due the day after, so that way you have enough time to actually do it. There's only one assignment like per lesson. Sometimes a lesson are 2 days and like spread it out. You also come like to bonus if you need more help. I tend to assign odds so you can check in the back of the book. But the issue with that is if you don't show work, you get 0 points because I give you the odd answers. Okay, so my solution, let's see, one solution is between negative 1 and negative 2.
11, 12, 11, 8.
Wait, what?
Like, the points, why'd you get so many points?
Because I had to have enough so that way I'd cross over the x-axis. Yeah, between x equals 5 and 6. So I have 2 solutions. One is between negative 1 and 2. The other is between 5 and 6. Cool, there's a problem like this on your homework. Do I have more? This one? Yeah. Okay. So this last one, just like reiterating, how do you find max or min? Yeah, you already know how to do this. So it's 13 problems. That way, the odds you can always check. I don't think it's too bad because some of them are you're literally just looking. Huh? 12. 11, 12. You guys can go like a minute or two early.